Alright, geometry students, this is the last shape that we need to learn about in order to find the surface area and volume of. So what's more important in this world than spheres? We have lots of objects like spheres in this world that we need to know the surface area and volume of. So you guys can see that I have two of the formulas written down here, so take a second to write those down. So, what do they all mean? In our surface area formula, it says that we want to take 4, multiply it times pi, and then that r again stands for the radius, and we want to square that. That's going to allow us to find the surface area of a sphere. Next, to find the volume of a sphere, we are going to take 4/3 times pi, and then again that r stands for our radius, and now because it's volume, we are going to cube it. Okay, so notice in these first two examples, they want us to find the surface area and volume of these spheres, and also they want our answers in exact form and rounded to the nearest tenth. Alright, so let's do our first one, surface area. Plugging in our information, it says we do 4 times pi, and then times my radius, which is 9, and then we are going to square it. When I type that into my calculator in exact form, I'm only going to multiply 9 squared and 4 together, which gives me 324 pi, and then this is going to be centimeters squared. So that's exact form, and then rounded to the nearest tenth, I'm going to multiply the 324 times pi, and when I do that, I get 1017.9 centimeters squared. So those are my surface area answers in exact form and rounded to the nearest tenth. Now I want to find the volume. Volume, we take 4/3 times pi times my radius, and now I cube it. Okay, so I'm going to show you guys how to type this into the calculator, just so that you guys know how to type this 4/3 in. I would do parentheses, 4 divided by 3, and then I would multiply that times 9 to the third power. So this is going to be our answer in exact form. It's going to be 972 pi centimeters cubed because this is volume. And then to round that to the nearest tenth, we will simply just multiply that times pi. So now I get 3053.6 centimeters cubed. So that is the surface area and volume of a sphere in exact form and rounded to the nearest tenth. Okay, so let's try another example. Notice in this example, though, they give us 4.5, which is our diameter. So when I do that, I want to make sure to plug in my radius. So my surface area is going to be 4 times pi, and then half of 4.5 is 2.25, and then we are going to square that. So in exact form, multiplying those together, I get 20.25 pi, and then that will be meters squared because this is area. To get that in decimal form, we multiply times pi to get 63.6 meters squared. So there's my surface area in exact form and rounded to the nearest tenth. Volume, we are going to take 4/3 times pi, and now my radius is 2.25, and we are going to cube it. Again, just to show you guys how this is plugged into the calculator, take 4 divided by 3, and we're going to multiply it by 2.25 to the third power. This is my exact form answer, so I want to make sure to write all those decimals to keep it in exact form. So that's going to be 15.1875 pi meters cubed. Now we take that answer and we multiply it times pi, so I get 47.7 meters cubed. Okay, so hopefully you guys feel comfortable when you are given a complete sphere how to find the surface area and volume. Okay, moving on to a different example. Now I want to find the surface area of a hemisphere. So you guys want to think about this, that this is going to be half of a sphere. So we're going to use our surface area formula and divide it by 2. But then don't forget that you have this flat area underneath, which is a circle. So we need to add that to it. So first we need to find the surface area of the sphere. And so by doing that, that is going to be 4 times pi times my radius squared. Okay, so I'm going to do 36 times 4 times pi in my calculator. And so that is going to give me 452.389. But now don't forget, we need to take that answer and divide it by 2 because this is only a hemisphere. It's half of a sphere. So that's going to be 226.2 centimeters squared. So that's just this outer part of our sphere. So now we need to remember that we have this flat area, so we need to find the area of just a circle. So recalling our formula, that's pi r squared. Our radius is 6, so I need to add this to 36 times pi. And so when I get my total answer after I add those together, I get 339.3 centimeters squared. So when you come across these problems, don't forget to find the surface area of the sphere. It's a hemisphere, so we divide it by 2, and then add the area of a circle, combine those together. Okay, next, now they want us to find the surface area of a sphere, and we know that the area of the great circle is approximately 220. Well, a great circle is kind of, think about it as this flat space right here, and a great circle always includes the radius. So using our area formula from up above, area is equal to pi r squared. And so I'm going to plug in 220 for the area, and I'm going to solve for my radius. So I'm going to take 220 and I'm going to divide that by pi. So that's going to be 70.028, and it continues on. That's set equal to r squared, and you guys remember that to get rid of something that's squared, you square root it. So that answer for our radius rounded to the nearest tenth is 8.4. So now to find the surface area of this sphere, we are going to take 4 times pi times that 8.4 squared, and that should give us our answer. So when we do that, we get for our final surface area 886.7 meters squared. Okay, next we want to find the volume of a hemisphere. So this is nice because to find the volume of a hemisphere, hemisphere means half, we just need to find the volume and divide it by 2. Alright, so our volume formula says we take 4/3 times pi times our radius. We're given the diameter, so we're going to take half of that and then we're going to cube it. So don't forget to use your parentheses for the 4/3, and then we're going to multiply that times 3 to the third power. So my total volume is 113.09, and it continues on. But remember, this is a hemisphere, so we want to divide that by 2. So my final volume is going to be 56.5 feet cubed. Okay, last example. We have 3 tennis balls, and they are packed oh so snugly in a can that's shaped like a right cylinder. So the diameter of each of these balls is 6.35 centimeters, and we're going to find the amount of the empty space between the balls and the can. Okay, so we need to remember some old formulas. We need to remember a cylinder formula, and then we also need to remember that these are tennis balls, so they're going to be shaped like spheres. Now, they told us that the diameter of each of these balls is 6.35. So that would be all of these are 6.35. And conveniently, if we take that and multiply it times 3, that's going to give us this height of our can, which is going to be 19.05. So that's pretty nice. So we want to find the empty space. So let's first find the volume of each tennis ball. So we'll say the sphere. So that's going to be 4/3 times pi, and then we want to take that 6.35 and divide that by 2 to just get our radius. So that's going to be 3.175 cubed. So I'm going to cube that, multiply it times pi, and then multiply it times 4 divided by 3 using those parentheses. So the volume of just one tennis ball is 134.1 centimeters cubed. But remember, we have 3 tennis balls, so I'm going to multiply that times 3. And so that's going to give me 402.3 centimeters cubed for all 3 tennis balls. Okay, now what I want to do is I want to find the volume of the cylinder. Okay, so we need to recall our formula for volume of a cylinder. So when I do that, the volume of a cylinder is going to be pi r squared times our height. So the radius of this can, now I know this picture doesn't show this very well, but these should all be touching. So the radius of the ball is also going to be the radius of the can. So we know that that is going to be 3.175 squared, and then we already found our height, which is 19.05. And remember, that's all those diameters of the tennis balls. So typing that into my calculator, I take pi times 3.175 squared times the 19.05. And when I do that, I get 603.3 rounded. So now I want to take the volume of my cylinder, the volume of my tennis balls, and I want to subtract those two, and that'll give me the space that's left over. So when I take 603.3 minus 402.3, I get left with a nice whole number of 201 centimeters cubed. So that is the volume or the space that's left over in that tennis can. Alright, so you guys know how to find the surface area and volume of a sphere. Have fun with your homework.